That was quick. The new digital version of the 936, which it's quite odd. In the package it says 936D, which is what I ordered, but this one is apparently a 937A. I've not actually opened it yet, so let's open it and find out what it is inside actually. It's an unboxing. It's rare that I do unboxings. It does say 936D. What will it say in the actual unit though? So we've got a box with presumably the soldering unit, the soldering iron stand, and the generic iron with the usual pointy bit in it. So let's unbag these things. First surprise, this is metal with this sort of plasticky insert in it. That's interesting. The iron is the generic type. Let's see what the unit looks like. British plug, that's nice. Well, British type plug. We'll see if it is actually. YCD936D. Okay, let's put this together. Well, let's actually, do we open it first? It would be a good idea to open it first and check the electrical integrity inside, so I think we'll do that. This should have, theoretically, a 3 amp fuse in it. It'd be nice if it had a 3 amp fuse. It may have a 13 amp fuse. It's got a 13 amp fuse. That would have been better as a 3 amp, but hey, 13 amps good at the moment. It may make it more dramatic if it malfunctions. So let's pop the lid in this. It's got deep screws. I'll need a deeper screwdriver. This actually arrived quite quickly. I'm just going to turn the brightness up a tiny wee bit here. Probably going to regret it, but that's okay. I'll turn it back down if I have to. Physically it looks very similar to the other one. I wonder if it's compatible with the retrofit fascias. I think it probably would be. I think there's a good chance that they've used the standard moulding throughout. The blue case is different though. That seems to be the main sort of feature difference between, well, apart from the fact it's digital, that seems to be the main identifier. So the same big fat transformer inside. Once again, there's no fuse in this little board here that on the switch. We've got the earth wire coming in. That is a wee bit loosish, that earth, so I'm just going to snug that up right now with a slightly bigger driver. That's better. And that earth wire just goes straight onto the board next in the vicinity of the connector, as they do. We've actually got two sets of windings here. I guess one of them might be a logic supply. Let's lift this off. So what is there to see? There's a multi-pin connector here. I wonder what that's for. The multi-pin connector looks as though it may be connected to these switches. I wonder if it's part of an automated calibration system. There's a little dinky processor type chip here, which is an 80 mega 8L, then underneath it says 8AU 1535C. Okay. This little thing down here, I wonder if that's just a little op amp or something. Oh no, it doesn't look like it. I'm not actually sure. OP07C. OP07C? Oh, I'll have to look that up. What else do we have? Really, it's just this is another of these ones that I can't easily take it out without desoldering, but to be honest, there's not an awful lot in there. It's just some discrete components. I'm guessing this is probably an op amp. As part of the temperature sensing. It certainly seems to be tied into these the temperature sensing pins on here. What about switching? Oh, there's the triac. If it is a triac, I think it probably is a triac. with an opto-isolator. The opto-isolator's under here feeding it from the processor. So that's a fairly straightforward arrangement. Let's just see, just out of interest, if the classic retrofit board fits in here. And it does appear to fit in there. Yep, it seems to fit in. Right, so we've ascertained the earthing, well, let's meter the earthing out, and we'll see if it goes all the way to the tip of the iron. So let's plug the iron in. I'm going to test this to see how good it is with calibration, so I'm going to change the bit in this iron for the my preferred tip, just for uniformity that I did with all the other tests. So that iron is now plugged in. We're looking for continuity between that pin and the iron, and that's we're getting it. So it is earthed. The transformer says, oh right, it says 24 volts AC and 10 volts AC. It seems to be specifically it's actually rated for the 936D, so I'm guessing it is a custom transformer for that task. Right, let's put this together again. Quite intrigued to try this out. Quite intrigued to see how you've set the temperature as well. So let's unplug the iron momentarily. It's just got the two buttons, so I might have to read the manual. But we'll try it without the manual first, as is always a good option. It's a good sign of simplicity if you can program it without having to resort to the manual. Good chunky screws. Remove the shreds of where they've been cutting themselves into the plastic where they've tapped in. And we'll just snug it up before I power it up. I'm looking at the holes on top of this stand here, and I'm wondering, they're not really ventilation holes. I wonder if they're for storing bits. Let's drop some bits in and see if it does actually accommodate them properly. Yeah, I suppose it could be kind of semi-used for that. Yeah, maybe not. Right, let's plug the iron in. And we'll put my preferred bit in it. I've got a spare one here. My favoured 3mm chiselled angled bit. It's got a metal core element, which is interesting. Should I say metal sleeved element. Just get that tip just the way I like it before I tightened it up. Yeah, that looks pretty good. Okay, well that's quite a loose fit in there. Actually that's a better fit in there than in other ones. If anything, just slightly too loose. No, it's not bad actually, it seems pretty good. Right, let's plug this in and power it up. And we'll see what happens. Right, switch. Says 350, showing the temperature going up. It doesn't flicker to my eye, it's just flickering to the iPad. So let's, I'm going to let that stabilise for a while. And once it's stabilised, I'm going to get this in, and I'm going to test the temperature. So I'm going to let that stabilise just for a few minutes, so it balances off, and then I'll be back and we'll test that. Right, so it's had some time to warm up and stabilise now. Let's check it for temperature. So I'm just going to tin the bit lightly and place it on the temperature gauge. So this is supposed to be 350. It's showing 390. 40 degrees. Okay, righty-ho. So it has to be calibrated 40 degrees down. Let's see if we can work this out ourselves. I see it says both buttons at once for calibration. Okay. Okay. Oh, that's not... Oh, I know what it is. Is it? Oh, no, this isn't really obvious initially. Ah, right, okay. So I want to calibrate at about 40 degrees centigrade lower. Is that going to do it? And then I want to bring this temperature down to 350 again, because I've obviously just adjusted that up again. Right, okay. Let's see if that's coming closer to 350 degrees now. Oh, look at that. That worked well. That's very impressive. Okay, so the calibration, I'm going to read the manual and I'll leave the information down below afterwards, but yeah, that actually worked. Rightio. Let's try setting this down to 320 degrees. And we'll see if it stores it. So it's flashing, and now it's saying 320. It'll take a wee while for the soldering iron to actually cool down to that. I should actually have maybe get a wet sponge to try and cool it down a wee bit faster. Let's try again. So 320, it may still be holding a bit of heat though. No, that's pretty good actually. That's not bad at all. So, what if I turn the power off to this? Will it remember that it was set at 320? Power off. Power on. It's just remembered the last setting. Okay. So yes, that looks quite neat actually. So the next thing to do is give it a test. So yep, so far it's quite quiet. Just a slight hum from it, nothing major. Yeah, I think I'm going to have to solder something with this. Right, let's give this a wee test, shall we? So I've got another of my little kits here. And I'm going to try, let's put the resistor in first and see how that goes. I've set the temperature to 350 degrees centigrade, just because that's what I tend to prefer working at the higher temperatures, just because it matches my speed, so to speak. I have a wee peek in the manual now, and it does say, right, where's my super luxury Xeron snips? Here we go. It does say try and minimise the temperature, keep the temperature as low as you're comfortable with, just to prolong the life of the bit. Someone was asking, how do I form the component leads, and normally for the standard component spacing I use my super expensive RS Components tool, the one that crops and bends the leads, but that's what I'd class as a professional item. It's just not affordable to Joe Bloggs, so to speak. And the only reason I bought that was because I was doing so much professional work at the time. Normally, if you want to just shape component leads, just grab the component and you can just pull it round, and the true electronic aficionados will say, oh no, that stresses the component leads and so on, but to be honest, for DIY fun, for just building stuff yourself, it's fine. So this is a Zener diode I'm popping in here. This is a little RGB controller I designed a while back. It was just designed as the smallest, well, not the smallest I could make it, but a smaller version of my RGB controller. And it was just designed to fit inside existing products. You know, instead of having the terminals and the end, it actually has pads you solder onto. And it economised to save space and keep the cost at a more affordable level, though obviously I can't compete against Chinese products. And it uses a resistive dropper, where it uses a 1K resistor to limit the current from the 12 volt supply, and that also passes, that powers the LED, and then it's clamped by a Zener diode to the 5 volt required by the processor. And the processor only requires about 1 milliamp of current, so that system works very well. It means it's super simple, it's very efficient because the LED is being powered by the LED takes some of the, it takes about 2 volts to drive that, so it's 12 volts minus the 0.6 volt of the diode, minus the 2 volt of the LED, and that then you're dropping it to 5 volts across the Zener, and the rest just gets dissipated as heat in the resistor, but it's so low that it's just negligible. It's not really a significant factor. So the components are all soldering in very nicely, I have to say. Let's try this SIL array. SIL is a package of resistors, which it just fits lots of resistors into one thin package. It saves space. So this one is effectively 4 separate resistors. So I'm just going to solder one pin at each end, make sure it's nice and straight, which it is, and then solder those. I have to say at the moment, this feels absolutely fine. I know there are a few critics of these irons saying that because they're not suitable for super high mass joints, but having said that, if you're doing a lot of high mass solder joints like big wires onto speakers or into big connectors, then you really need a dedicated iron for that, because they're, you know, a small iron like this is perfect for doing things like integrated circuits and stuff like that, and just resistors and the common components. But if you're doing a lot of the, you know, high mass ones, you need a proper high mass iron. And that iron is not really 100% suited. It tends to be chunkier, so it's not so suitable for the more delicate jobs. The slight niggle I've got with this at the moment is you tend to almost pick up the whole stand. It really is. You have to get used to the fact that it's going in like that and not sort of pick it up at an angle. Having said that, it'd normally be tucked at the back of the bench out of the way. It's not sticky, which is good. It's not dragging it horizontally like the other holders. It seems quite a good thing. So I'm soldering this socket. Someone was also asking about the socket, because the ones I use have the little round pins, receptacles in the top. And these are what are called turned pin sockets. They're more expensive than the traditional flat blade sockets, but they're just so much better quality. The kits I tend to always use these now. Initially with this kit I shipped it out with the flat terminals, but latterly decided, nah, you know what, turn pin all the way, it's just a better quality thing. Yeah, I have to say, so far, top marks to this. I'm very impressed with that calibration accuracy, and the fact it can be done from the front buttons really beats twiddling through here and sort of waiting and twiddling again. It's nice that you get the offset and you can just type it into that, and I'll go over that at the end of the video again because it's worth covering again. It's a neat solution. The downside of this one is that if it ever goes wrong electronically, like the little processor fails or stuff like that, it may not be repairable. That processor is, you know, it's not something you could just reprogram another without the correct software, and it would be quite hard to solder in because it's a little surface mount thing. So that makes it less repairable. Having said that, it's got the 2 windings in the transformer, the 10 volt for the logic and the 24 volts for the soldering iron. So technically speaking, if this fits in, if your soldering iron, if the electronics did go in it, you could put one of these cheap panels in that cost about £5 on eBay, and just use the 24 volt winding and just tape off the 5 volt winding, and that should restore it to a functional soldering iron, albeit it will be the traditional analogue type. That is one downside to when they try to make the electronics too fancy, it just makes it unserviceable sometimes. It's okay if something like a triac goes or something like that, it's easy to change, but if the processor goes, it kind of renders the equipment, you know, inoperative. So many times you see things like an elevator controller where they've used a dedicated PLC, and it's quite an old elevator, and the PLC just suddenly one day loses its program. And if the company's gone out of business, you know, that one component renders that, unless you can get someone to reprogram that PLC, but that would be like designing all the control system for the lift. So sometimes you can overcomplicate things. I look at these factory machines that have all the computerized control, And it's great when they're working, but when they go wrong, it's sometimes, if it's really at a hardcore electronic level, it can make repair the machines virtually impossible, particularly if the company that supplied them has gone out of business. So yep, I'm just going to plod on. I'm going to put all these components on here, and so far I'm thinking this solder iron is very usable indeed. It's well up to the standard of the other generic Chinese clones, and I know there's snobs that say, you know, these soldering irons aren't, you know, what professionals would use. I'd be perfectly happy using this. It's, you know, I've been using one for a while now. It took a wee bit of time to switch over from my traditional Antex, because every iron feels different. If someone tries to switch over from Antex to Weller or Weller to Antex, they just, because you're so in tune to a particular iron and the way you work, it can, you know, it takes a wee while to adapt, and it just feels wrong. It's like switching from coffee to tea. It just, you know, nothing feels right initially. But you quickly get used to it. Yep, that is perfectly acceptable. So let's take a look again at how you calibrate it and change the temperature. In fact, you know what? Let's put in a different iron. One of these random irons I had knocking about. I had a pile knocking about. Here's one. So let's recap no, actually I'll come back and do that afterwards. So I'm just going to pause. I'm going to plug this iron in. It does say in the instructions you should turn it off before unplugging plug iron. So I'm going to turn it off, plug in the other iron. Let's see what happens when I turn it on. Let's see how oh, I'm wondering, is that iron is that using a thermistor then? Panic over. I have discovered these have the same thermocouple. What actually happened there is that if the thermocouple's connected, the minimum temperature read is 91 degrees, which it was doing. It wasn't heating the iron because this connector is just slightly different. It's just tolerance thing, that it wasn't actually powering the heating element in it. So the heating element was staying cold, sitting at 91 degrees. It does have the type K-ish thermocouple, and as such, let's find out. So this is set for 350 degrees centigrade at the moment. I'll just show that so you can see. And this is a generic cheapy off-the-shelf iron off eBay. It's worth mentioning the iron that comes with it has got the soft, rubbery, silicone type cable. That's quite good. So let's check this one out. Bear in mind this has been calibrated for the other iron, so I'm going to have to probably calibrate it back if it's not close. This one is showing 310, so it's going to have to go up 40 degrees centigrade. So if we put it back into calibration mode, by holding both the buttons, okay, so it was minus 30, so pretty much back to zero. So just to recap there, this is the first really time I've tried this iron, so pressing both buttons until that flashes 3 or 4 times enters the calibration mode. What if I, let's try that again. No, it goes straight into calibration mode. If you press both buttons at once, it goes in, but if you don't instantly start changing the calibration value, and it's not got good button debouncing, but and then it stores it. Yeah, if you don't instantly change start changing, it will just go back to normal temperature mode, which is reasonable enough. So let's see how that iron's doing now. I'm not sure how fast the temperature will drop off, and I'll clean the bit. I'll put some more solder on, and we'll see if it's close to 350. It's going much close to 350. It's on its way. It's not quite reached that yet. I'll leave it a moment to let it stabilise. So yeah, initially, as I say, I thought that was a thermistor-based heating element in it because it seemed to be incompatible, but it must be that just the bottom range is 91 degrees centigrade of this. That's the sort of minimum temperature it's going to read, because it doesn't really need to hold much, you know, it doesn't need to read below that, because nobody's ever going to use a solder iron below that range. It's also notable that once the calibration had been done, the accuracy of the temperature was technically speaking, within 1%. That's very impressive. That's quite neat. The digital is maybe preferable for that aspect. It's not quite got that sort of it's not got the serviceability of one of these, but it's just, you know, it's nicer for that feature. So let's see how it's stabilising out. Touch a wee bit more fresh solder on. Touch it on the thermocouple. Oh, look at that. That's very good. That's really good, because as long as it's within a few degrees centigrade, that's just fine. So if anything, if I wanted that to be on the ball, and it doesn't really have to be on the ball, I could press that and then immediately nudge it down, say 5 degrees. That's very good. I think this is quite a neat little iron. I mean, if you've just bought one of these, then these are also absolutely fine, but this is just an interesting variant on it. Not as serviceable as these ones, but having said that, at least it gives you the option that you could put one of these boards into it. Yes, this is all good. This is making soldering so much cheaper and more affordable. Yep, I do quite like this. Just wondering if there's anything else I can do here, anything else that really needs covered, and I think that pretty much covers it. It's really good for soldering. It takes the standard bits, which is really nice, the standard soldering iron handles, which makes ongoing use of this. I mean, the bits are $1 each, the handles are, you know, the whole handle assembly is about $3, but note that I did have that slight connection issue. It requires really pushed in hard and this little collet tightened up. So that's something to watch out for if it just displays 91 degrees centigrade and doesn't go anywhere. But yeah, I think all these irons, these sort of Hakko type clones, these generic Chinese irons, are turning out to be really quite usable. Very good indeed.